Okay, so what we need to do is we need to print the prime factorization of every number. We have 10 raised to power up to 10 raised to power 5 test cases, and this value can go up to 10 raised to power 7 as well, because outside int main the maximum size of array allowed is 10 raised to power 7. So it will be something similar to sieve. It will be something similar to sieve. Just go watch it out. The sieve lecture is just a 5-7 minute lecture. So here what we'll do is, let's say 0 1 2 3 4 5 6 7 blah 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 up to, like, let's say some number up to 10 raised to power 7. We have an array, right? So what we will do is, for each and every number, number, what I'll do is, instead of marking it to true false or 0 0 0, like we were doing in the sieve, you can see here, like in sieve what we were doing is we were marking it as 0. But what we will do is we will mark it as the smallest prime number. For a 10, what is the smallest prime factor? Sorry, smallest prime factor, that is 2. So I'll mark this 10 to 2. For 12 also it's 2, it's not 3. Though 3 is a prime factor of 12, 4 is also, but I'll mark it as 2, right? So here 2, here 3, here again 2, again here, let's say 2. Now what will happen is, similar to sieve, I will write a code and I will mark the smallest prime factors. Okay, I will mark the smallest prime factors. I will mark the smallest prime factors. Now as soon as you mark the smallest prime factor, let's say we what will happen, let's name this array as smallest prime factors. So let's say SPF, the short form. So let's mark it as SPF. Then you simply need to run a while loop while n is greater than 1. While n is greater than 1, simply do one thing: see out, see out. What we need to see out is SPF of I, SPF of n, SPF of n, and then n will become n divided by SPF of n, right? So now what's happening? Let's take the example of 100, right? So for 100, somewhere in this array, for 100, we know that the smallest prime factor 2 is marked. 2 is marked, right? So I will see out 2 here. I will see out 2 here. Then n will become n divided by SP of n. That is 100 divided by 2. It will become 50. So now for 50, somewhere for 50, again, the smallest prime factor marked is 2. So again it will print 2. Now 50 will become 25. So for 25, it will again check the smallest prime factor. So for 25, somewhere it will be marked 5. So it will print 5. So till n is greater than 1, it will keep printing the smallest prime factors of the number we are getting. And that is what we need in the prime factorization. Now, let's say if we have 100, if we are doing this thing, so what we are doing at each and every step, we just need the smallest prime factor of n. So this is my n, right? So this is n by 2, then this is 50 by 2, 25 by 5, 5 by 5, right? So at each and every step for n, we are needing the smallest prime factors. So we are using the same intuition, that in our the smallest prime factor array, what we are doing is, for each and every number, we are marking it, it's a smallest prime number. We are marking its smallest prime number, and then we are simply running a while loop till n is greater than 1. We will print the smallest prime number for n, then we will reduce n by the smallest, we will divide it with the smallest prime factor, and then this way we will be able to print the this thing. Obviously this operation will be big O of 1, this operation big O of 1, so it will run in the big O of n time complexity. If let's say if we have the t test cases, sorry, if we have the t test cases, right? So it will learn in a it will go in a constant time, right? For if overall we have t test cases, so the time complexity of will be big O of t only. Okay, so let's try writing the code here. So what we will do is, I'm just copy paste, let me just copy paste this thing. What will happen is, let's name this as SPF, and it will be this time 1 2 3 4 5 6 7, right? Everything will be same, everything will be same. So 1 2 3 4 5 6 7. Yeah. So now what I need to check is everything will be similar. Now there will be just one difference, that instead of marking to it to 0, and also one more thing here, while marking for sieve, I know that we were starting from I cross I, but there is a possibility that 30 is already marked with 2, right? But in case of sieve, we are marking it with 5 as well again, right? We were marking it with 5 as well again, but even it's already marked with 2. So we need to add an extra if condition here within this for loop as well, that if it's not previously marked, okay. So everywhere, let me make it as SPF, right? So I will say if SPF of J is equal to J, then and then only SPF of J will be equal to I. I'll be marking it to I this time. Okay. So I'll be marking it to I, right? So then in our main program, what I'll do is, so as per our problem statement, let's say we have T test cases. So let's say int T, then I'll say C in T, then while uh, T minus minus, for every test case, let's say we have a number n, and we need to see in n. For every n, I'll say while n is greater than 1, what I need to do is, we need to see out SPF of n, and then n will become n divided by SPF of n, and also let's name this function is compute SPF, and I will call this function here. Yeah, so it will work, right? So basically we will be able to print the prime factorization of all the numbers, right? So that is all about the prime factorization. So in next lecture we will be covering the segmented sieve. Okay, so we'll see you in the next lecture.